Hello everyone, welcome to the weekly live session for the NPTEL course Blockchain and its Applications. I am Sai Venkatakrishnan, a PhD scholar from the Department of Computer Science and Engineering at IIT Madras. So I'll be conducting the live sessions for this NPTEL course. And for those who are joining for the first time in these live sessions, the agenda of this live session is if you have any queries pertaining to the week's lecture or the assignment or something, you can raise the query, and I'll try to answer my best for those queries, right? So I may not be able to answer all the queries, like if not, like I can um, take some time and I'll reply it back in a day or so. So yeah, so any queries pertaining to the weekly lectures you are having? I see Ganesh has raised his hand. So if you want to ask any queries or something, you can either post it in the chat box or um, unmute yourself and ask. Just raise your hand and you can unmute yourself and ask. Okay. So first, Ganesh has raised his hand. So Ganesh, do you have any specific query? Hello, Ganesh. Ganesh Govind, are you there? You have raised your hand. Okay, it seems Ganesh is not there. Okay. Yasha Dubey. Okay.
Yes,
So,
sir. Yes, sir.
yeah. So you have posted a query, a question that
Yeah.
how the leader is decided if two miners solve the puzzle at same time. Okay.
Yes.
So if two miners solve the puzzle at the same time, then it's one of their nodes will only one of their blocks will only get included in the blockchain, and it just depends on which miner has maximum connectivity to the other nodes. So say like you have excuse me, say like you have miner one. So assume like there are six nodes, and right, and assume like node 1 is actually miner 1 and node 4 is miner 4. So these are just the two miners are there, and both are trying to add a block n to the blockchain, right? So this is block n and this is block n prime, and now say like node 1 is connected to node 2, whereas node 4 is connected to node 5 directly, as well as node 6 and node 3. Okay, as well as node 2. So assume like this the connection. Say if node 1, the miner 1 needs to propagate their block bn, right? It has to first go to node 2, and then it has to go to node 3, like step by step, whereas node 4 or miner 4 has better connectivity compared to um, the minor one, and they can directly just transmit the block B and prime to all the other nodes. So it's just like uh, random ordering only. So if say like if this block is accepted, then it's not like this block is wrong, but it's just like out of time. So the minor one has to start from again, mine a new block and send it.
Okay. Okay. Thank you, sir.
Okay.
Sir, I have one more question.
Yeah.
Yeah. Sir, actually, when we are saying we are doing mining, then is it for only transactions? And when we are saying that we are running smart contracts, then is it for only other applications?
I didn't get your doubt. So, what's your doubt? Like mining, when is it done? Is it?
When we are saying कि mining is done by miners,
Right.
or there is a mining, then is that mining is for transactions only, that if we are sending money from one node to another,
Okay. Or is it
and
for smart contracts?
and when we are saying that smart contract is running,
Right.
then it is for other application
Right. So the way you should
beyond
look.
cryptocurrency.
Yeah, so I get your doubt. So your doubt is like, what does mining have to do with transactions or smart contracts, right?
Yeah, yeah.
So, so basically, you have so assume like you have a blockchain. So this is block one, block two, and block three. It's all connected. So like a hash chain, right? It's connected via the previous blocks a hash. So I assume
Yes,
like this, Now some block has to be added, and what's there in this block, block B4 has to be added, and if it has to be added, it should not be the case that what's inside the block in the first place, right? So there'll be transactions, right? If you take the notion of Bitcoin, there's just Bitcoin as an amount, that's it. You don't have the notion of smart contracts in Bitcoin. But if you take, for example, an Ethereum blockchain, I guess in a couple of weeks in the future, like week 5 or something, they'll be discussing about Ethereum blockchain. So
yes.
Ethereum blockchain will contain its native token called as Ether. Okay, so Ether and then also smart contracts. Okay. So both these type of, so each is like a transaction basically. So we don't differentiate that this is like a transaction and this is a smart contract. It's not like that. It's just
Mm.
like two different types of transactions. So one transaction is sending the native token or the cryptocurrency Ether from one account to another. The other transaction is like a smart contract. That's it. And
Means
both
we are adding some information, like we are making a block of some personal information
in which one?
in a smart contract case. If we are, means if suppose we are following some suppose Ethereum blockchain, and we are adding a information block, or we are making a chain of information of some patient,
Okay.
then how that block is means like authenticated, or means
So,
how,
like,
yeah,
so you are asking like how will the transaction look like in the case of a smart contract? It
yes.
just contains some
Means,
data.
I want to say that that is also known as transaction, or we can term it as transaction if we are adding some informational block.
Right. So there are like different types of transactions. So the smart contract, or like if you just want to store some information, there is a particular format for the transaction, and we just have to follow that transaction format, and that will get included in the blockchain, in the block, and that block as a whole will be included in the blockchain by the miner. So the step how, like if you submit any transaction, how it gets included in the blockchain is, say like I'm a user. Okay, so the user, I'll just have a like a laptop or something. I'll just post a transaction stating that I want to have the smart contract, or say I want to use these many bitcoins or ether to some other person, some other account, right? So I'll just post a transaction T1, and I'll just propagate this transaction to all the nodes that I know. Okay, so I am not the miner. I'm creating a transaction. I'm sending it to all the miner nodes I know. Now it's up to the miner nodes to decide whether to take up this transaction or not. So what they'll do, if they decide to take this transaction, they will, along with this T1, they will have like other transactions also. All these put together, they will place it in a block, and they will solve the puzzle and try to add this block to the blockchain.
Okay, thank you, sir.
Okay, cool. Yeah. So, Ganesh, you have raised your hand. Do you have any queries?
Yes, sir.
Yeah.
Sir, how the transactions are verified in Bitcoin, sir,
How the
and how
transactions?
they are added to the blocks.
Okay, how the transactions are added to the blocks? How they are verified in the Bitcoin? Okay. So verified as in what do you want to do? Like whether they are correct or not? That you are asking, is it?
Yes, sir. And how to detect the double spending that like that, sir.
Okay, how to detect double spending? Okay, good question. Right. Okay, and the other question was how do you? Yeah, can you repeat it? Like one is verifying transaction, identifying double spending.
And how to identify in double spending and how the transactions are verified, sir.
How the transactions are verified. Okay, right. Okay. Yeah. So this requires like a bit of explanation. So I will
Yes.
just take up any other questions others have, and I'll come to your question.
Okay, sir.
Okay. So in the chat message, I see course resource. They have posted a query, six queries on the discussion forum. Okay. Okay. So I'm just looking at the discussion forum queries. Which of the below are blockchain based app examples? UTXO, why is it not accepted? Okay. So for this course resource, are you there? Course resource, are you there? You had posted a query on the message. So why is UTXO not accepted as an answer in assignment 1 is UTXO is not a blockchain application. It's just a term used in Bitcoin specifically. It's not like a blockchain widely used term. Um, for example, like hash or puzzle is like widely used in a blockchain terminology, but UTXO is very specific to Bitcoin. So it's not like a blockchain based application. So you might have come across this term UTXO in Bitcoin websites or like explanations regarding Bitcoin, but it's not a blockchain based application. It's just a term used. So how like you use a private key and public key RSA like that in a blockchain setting in the same way. Uh, there is another question by course resource in assignment 1 question 9. Genesis block may not contain first transaction or first transaction block, last transaction block. The accepted answer is C. So there can be at least two meanings. Last transaction block is now if there is only one block in the chain, then the Genesis block contains the last transaction because it's indeed the first and the last block. Mm, what's the last transaction? So, like, okay, so you sort of like try to reason it. The reason is like pretty cleverly, but on the face meaning of a Genesis block is just like say like the birth of the blockchain. That's the first block that's available with all the information. So that's not like treated as a normal block. It just it's just the first block, and it might be the case that there won't be a transaction on that block also. It can just be empty. But it may not it but it's not the last transaction block for sure, because just like view it in this way, right? Like a baby girl is born on the first day, and you won't be telling what's the is it the last day of the baby or not. Like that sounds like weird, but the reason what you have mentioned is like okay, but usually Genesis block is the first block, that's it. So you assume the blocks to be mined after the Genesis block to be added. Right. And also it might be the case that the Genesis block may not contain any transactions also. It may just specify some parameters, or it might just specify, it might just be an empty block on top of which the other blocks should just be added. So, okay. And we have question 5. Minor nodes only execute new transactions but cannot verify previous transaction hash. Is it true or false? Accepted answer is false. Hmm. Okay, so um, see, okay, minor nodes can only execute new transactions but cannot verify previous transaction. You had mentioned true, is it? And but the answer is false. So it verifies indeed. Is that correct? So why it is false in this case is because you will, of course, every node should verify the previous transaction hash, and the course resource user has shared a picture on the blockchain. So let me just share the screen for others also, so that they just know what I am discussing. So here's the question, it's on the discussion forum. The question is, why is it false? Why is true not the answer? So the question is, minor nodes only execute new transactions but cannot verify previous transaction hash. True or false? So the answer is false, but course resource is telling it should be true. It should not be true. It's false, because minor nodes will verify the previous transaction hash. They have shared a picture from a book and highlighted a portion. Let me just open that image. It's not low. Okay, it's low. So it says transactions broadcasted are validated by full nodes. Okay. And purpose of mining is not verification but putting transactions into a sequence in a specific order. So not sure from which stack exchange. See, you can view it in this way, right? Miners can see, anyone can just place any transactions in the block, but miner nodes specifically, they are the ones which add these transactions in the block and place it on the place it in the blockchain. And for that, they have to spend considerable resources to try solving the hash puzzle, which will take up a lot of electricity and power requirements, and they should have that proper infrastructure. And in return, they get a reward like 6.25 bitcoins or half of that, something like that, the Bitcoin mining reward. Now, what happens is, now once they add a block, once they create a block and solve the puzzle for that block, they will propagate that block along with the puzzle answer to all the other nodes. Now, what the other nodes will do is they won't just blindly add this block to the top of the blockchain. They will verify that whether the block is well formed, thus all the transactions within the block follow some set of rules. This double spending does not occur and all those things. Only if all the transactions within the block satisfy these conditions, then only the block is said to be valid, and the block will be added to the blockchain by all the nodes in consensus uniformly. If the transactions are not proper, if they are not valid, it means the block itself is invalid, and even though the puzzle is correct and the miner has solved the puzzle, the computational resource that the miner has spent in solving, it's a complete waste, because now it won't be accepted by any of the other nodes. And we assume that majority of the hash power is honest, and the nodes are honest, so those nodes will sort of reject the block, that invalid block containing these invalid transactions. So the minor nodes, yeah, you can tell, like, they need not verify. They see, the question is, they cannot verify previous transactions, so it's the decision left up to them. So they can just blindly put all the transactions in a block and leave it for luck that the block is valid. But they can verify the transaction hash. So you should just look at the question this way. So it's not like they may not verify, it's like they cannot verify. May not and cannot is different. So they have a choice to verify or not. So that's what this question is all about. And that's question 5. Now question 8. Yeah, so this question is like a typo, I guess. So options B and D seem similar, but actually option D should have a extra capital I over there actually. Like 1, 2, and third option, all these options are correct. So I guess you have pinged NPTEL, so they will probably re-evaluate uh, this question. And finally, we have question 6, which is asked: which of the following is true for using a digital signature, A and C? It supports user authentication. Um, yeah, yeah. So this even I'm not sure. So this I'm not sure even whether it's correct or not. Um, yeah, yeah. This I should request the TAs from the course, or the professor to clarify. Okay. So if so, course resource, I have sort of tried to answer all the queries that you have asked on the discussion forum. Is that okay with you? The explanations. Um, okay. Thank you. So in that case, let's resume. Okay. So there are multiple questions in the chat box. So Shriman has asked, if I have to submit a transaction, do I need to join a blockchain network? Can I submit a transaction by connecting to one of the nodes which already joined the network without me joining? If so, how do I know the identity of those nodes? Are the script pub and script sig recorded into the block? When do these scripts execute? Are those scripts executed by each node? I don't see the actual amount transferred in part of the script sig. When Alice sends money to Bob, why Bob has to explicitly reclaim that money? Why can the money get added to Bob's account as part of the transaction explicitly? Okay. So these are all related to sort of Ganesh's question, like how do we prevent double spending and all those things. Um, Hemant Sharma, where is the data we upload on the blockchain is saved, but where is its code? That's the process. What's the process behind it? Okay. The numerical Sandeep has asked, numerical examples discussed in the course are not sufficient. Sandeep, what numerical examples are you referring to? Sandeep, what numerical examples?
Just like what are given in the assignment, like finding the say, Bitcoin scripts and that type of hashing questions. That week number
Directly you can use Google, like do you have tools for finding the hash and those things? So that's
because
so
that type or example what is given, it's just like say it is four. You can refer that quick three number question number four that that beats say 4 bits examples was given. Whether that query is coming about, the question is coming about 6 bit difficulty bits or maybe some 8 bit also
okay, so
later.
okay,
What
so
type of that type in consideration we have to do that time? That I'm not sure, not getting from this course.
okay, so actually this week's assignment I cannot be discussing. I cannot be giving answers for those.
No,
Uh,
I'm not asking for answer. I'm asking the in later also maybe in example some that type of question may come with 8 bit or 6 bit. Then what type of only 4 bit
yeah,
this type of discussion has been there, but for future preparation,
yeah, I
if I
get it.
get some
Have you
different
posted
types of the
a
example, then yes, yes,
Yeah, have
please
you
can.
posted a query on the forum?
No, I'm not posted.
Yeah, please do post it.
Okay.
Yeah, course resource. I will do my best in trying to contact the backend team and get the assignment thing sorted out. You can also
Mhm.
just from your side try to contact mail the NPTEL team directly, uh,
Mhm.
and yeah, try to get the question corrected. So like, yeah,
No, I am not question correcting. I have to just just actually extend our knowledge also. Maybe there are lots of things are there which is not covered in the course, but this type of this,
uh,
whatever given,
yeah.
if we can get some more resources, then we can go through that.
Yeah, if you post a query on the forum, I'll I'll reply it with an example or something like that. So,
Okay, sure, sure, I will do it.
yeah. Shriman has again asked to perform a transaction involving money transfer. Each node has to validate. Do we need to traverse all the way from replay each and every transaction? Seems to be very time consuming. Right, okay, I get it. Your doubt. Yeah, so whatever Shriman, Hemant, all your doubts and even Ganesh's doubt is sort of interlinked, and it's better if I just club all these things and answer it together. So this will take like a lot of time. Like from the start, I should answer. So Shraddha has raised you have raised your hand. Do you have any question apart from this?
Yes, sir, good evening.
Or
So what is the role? Hello?
yeah, hello,
Yes,
Shraddha.
sir.
Yeah.
Yes, sir. So what is the role of Bitcoin in blockchain?
Okay, what's the role of Bitcoin?
Yes, sir, in blockchain.
Okay, so it's not like Bitcoin and blockchain. Like they are using blockchain technology to implement Bitcoin. So
Okay.
thing like electricity, blockchain has electricity, and you have multiple appliances which use electricity. And
Okay,
similarly, you
sir.
have blockchain, and Bitcoin is one application which is made possible because of blockchain.
Okay, sir, understood. Thank you, sir.
Okay. Mahendra, do you have any query apart from the ones that in the chat or Ganesh has asked?
Yeah, I wanted to know how do we calculate the difficulty level from the bits which we have? I mean, how do we arrive at that difficulty level of the network?
Okay, there's a specific formula to it. Maybe like
Yes.
if you, so I don't remember that formula from the top of my head. So if you post a question on the forum, maybe I can share a link with it. Link to
Yeah,
that formula.
formula is actually provided in the
Okay.
in the course material, but it's not very explanatory. For example, if I change the number of bytes, formula is given only with respect to 4 bytes. what if I change the number of bytes to something else? Then how do those coefficient and those two things work in that case? That is not very actually evident.
Okay, I'm not gone through that slide.
Okay, maybe I will just put it on the chat. I'll just
You
let me see.
you
I'll
can
just
like post it on the forum. Can just share a link where that formula is explained, something like that. I know a
okay.
couple of links for that.
Okay. And the second one which I had was maybe it's related to what Ganesh has asked. I just want to know how do we actually, for example, if A is sending money to say B, then B provides a public key to A,
Right.
and A sends it along with his or her signature to that public key.
Okay.
Now B has received it in its account. So when B is sending to the public key of say C, how is it mapped to whatever he has received from A? How do these two get mapped? That is not very clear. Maybe
Okay. Yeah, I get your doubt. Okay. So this the only question you have?
yeah.
Okay, sure. I'll answer that along with the others.
Okay, sure. Thanks.
Okay. Shraddha, you have raised your hand again. You have any other query?
No, sir.
Okay, then you can lower your hand. Hemant, do you have any query? Okay. Ganesh, you have any other query apart from the one that you asked previously?
Yes, sir. I have a doubt.
Uh,
Sir,
yeah,
around 800 transactions is converted into a one block, no, sir?
yeah,
If even one transaction was failed, the block is also failed.
yeah. Block also fails. Yes.
Then remaining transactions will be affected, no, sir?
Yeah, it's just like those transactions. It won't get deleted per se. It will just be there, and you will just add it in a new block. That's it.
And again, what is the 6 steps confirmation like that? It will be there, no, sir, in Bitcoin.
What?
6 step confirmations. I don't know, but I have seen in the YouTube, sir. I'm asking.
Six step. I don't know of the term.
Okay, sir. Okay.
Okay. Shraddha, you have raised
Uh,
your hand.
yes, sir. So it is possible to modify the data written in the block.
Is it possible to modify the data region in the block?
Yes, sir. Written in the block, right?
Which one you have to modify? Data
Possible,
size, is it?
like any type of data, if we written in the block, then it will be modified or not modified.
So you're asking in the blockchain whether we can modify data already added?
Yeah, or not. Yeah, yeah.
No, that we cannot
It is
do.
possible, sir.
No, that's not
Okay,
possible.
it is not.
So blockchain is
Okay,
the advantage of a blockchain is it's an immutable append-only ledger.
okay, okay. Okay, sir.
Okay. Ganesh, you have raised your hand.
Sir, sir, in Bitcoin, why did they use the script public instead of normal public?
Yeah, I'll answer all those things. Okay. So is that it? Then I'll get started with the chunk of all your doubts that you have asked. So first of all, can anyone tell me what is the purpose of Bitcoin? Can anyone like type it in the chat box or try to tell? Why should we need Bitcoin in the first place? Like, so there's this founder Satoshi Nakamoto or like someone, some anonymous guy, or even like a female. So no centralized authority. Okay, right,
Sir, to remove the third parties involving this the transactions.
right. So to remove the third party. Okay, good. So the main aim of Bitcoin, like the goal of Bitcoin is to mimic what happens with your physical cash. Okay, so the easy way to understand what happens in the Bitcoin is to understand what happens in your physical cash. Okay, um, in your current world, you have like two types of transactions that are occurring with your real world money. So one, you will say when you go to a stall and try to buy some things, either you will take out your purse or wallet and take out some money from it, cash, and give it to the store, the shopkeeper, or else you will give a card or something which will directly deduct money from your account that you maintain in the bank. So Bitcoin wants to mimic the type of transactions that you perform with your physical cash, right? So it's not, and so it wants to mimic that the physical cash and make it digital. So that's the one single goal of Bitcoin. So you should be clear in that, okay? And by digital cash, what it wants to achieve is there should be no bank in between. It should be There should be privacy, and it should be fully decentralized, and anyone can transact from anywhere. It should be borderless. So for example, how this maps to physical cash, right? So when you take a physical cash transaction, so for now just assume bank transactions are not there. You just leave out bank transactions and assume the entire only physical cash transactions are there. So what's the advantage with having physical cash, right? Why do like governments and most of the law agencies, like in your news or something, you would have seen news clippings like there's income tax raid or enforcement directorate raid or something. Why do they come and raid in the first place? Because there's a lot of physical cash money laundering or something happening, right? It's not like account to account, most probably it won't be going, but physical cash itself they would have been holding. And this physical cash is usually it helps in privacy. So say I have a 2000 rupee note and I give it to the shopkeeper. There is no way the shopkeeper can assert whether I got the 2000 rupee, is it like white money or black money, whether it came from an illegal sale of goods or whether it came from my salary, right? So seeing a 2000 rupee note, you cannot verify. So you can just see whether it's fake or not, but you cannot, if it's a real currency note, you cannot tell the source of that currency note. So that's the beauty with physical cash. And also there is no specific owner to that physical cash, as in like if I take a specific currency note with some ID numbers present on it, like 2567, like that, some numbers present on it, right? It's not like using that number I can find, okay, this specific person Akshay had is the owner of this physical note. So for example, if you take your bank account, right, by looking at the account number you can specify who is the owner of that account, right? But in a physical currency note, it's not, there is no concept of an owner or something. It's just that whoever has that currency note physically at that instance of time will be able to do the transaction, will be able to buy things using that physical currency note. Okay, so till here you're clear, right? What's the advantage with physical cash? Okay, I take it as an yes. So now Bitcoin wants to mimic this sort of physical cash to the digital world. Murali, you have raised your hand. You have queries in this explanation that I have mentioned.
Thank you, sir. I have a basic doubt. Normally, this is regarding the distributed system. When suppose if you take
Murali,
Google.
Murali, just hold on. Like after this explanation of Bitcoin, can we come to your doubt? Like this will.
Okay, sir.
I
Thank you,
don't
sir.
want to disturb the flow. So yeah.
Okay.
Okay. Sorry. Yeah. Thank you. So the main goal of Bitcoin is to get this physical cash into the digital world with no banks in between. So when you have a physical currency note in your hand, you don't have to go to a bank to get permission to spend that note, right? You can just go to a shopkeeper and spend it. So there is no bank in between for in a physical cash. It's privacy. Like they don't know whether it's yours or someone else. You might have stolen that currency note also. So they won't know the source of that currency note, and it's fully decentralized, as in without any internet connection or without anyone overseeing, you can do the transactions using your currency notes. And here we just have like Indian currency note has to be within Indian borders, but Bitcoin, since it's like digital, it has no borders. Their aim is to transact from anywhere. It should be borderless. Okay, so just see how these 4 points correspond to the properties of physical cash. Okay, so this is the main goal of Bitcoin, to find a digital alternative for all the physical cash. Okay, so a transaction in a real world, like say Akshay wants to pay to Bharat and he wants to spend 2000 rupees note. What's the proof that he has ownership of that 2000 rupees? The ownership or the proof is he has that physical note in his hands, right? So that's the only proof. And if that proof is able to show, he can just pass over the note and give it to give it Akshay can give it to Bharat, and that's how a transaction takes place. Now in uh, a transaction in a Bitcoin world, how will it look like on the like a high level overview? So how it will look like is so before going into this, right? Um, okay, so a transaction in Bitcoin world will sort of it will have Akshay's, so no need to understand this private key and public key stuff now itself. I'll just flash this out. So it just tells like Akshay and then Bharat, and the amount will be like in bitcoins, 10 bitcoins. Okay, and the ownership, how will Akshay show is it should be some proof. In the physical world, the proof is he has the Akshay has the currency note in his hand. But in a Bitcoin world, everything is bitcoins, like digital, right? So what does a Bitcoin actually denote? So does anyone know what a Bitcoin actually is? Denotes in the digital world. Has anyone seen it or tried to understand?
Can I say it's equal to gold?
No, it's not equivalent to gold something. Um, in the real world, your physical cash is represented in this note format, printed on paper or plastic, something like that. In the digital world, your digital cash, in what ways, in what form is it represented? Is it like a unique ID, or is it like okay? So Shriman tells it's a value computed from the ledger. Sort of, yes, right. Yeah, it is sort of value computed from the ledger. Okay. So any other guesses? Anyone else? Uh, very sorry. I'm back. Sorry. Yeah. So yeah, we left it like what the Bitcoin actually represents, right? Um, So Shriman has mentioned, okay, it's a value computed from the ledger. Vegeta is similar to GPay, Amazon wallet. Okay, so it's not GPay, Amazon wallet. It's not like that. Shriman is like pretty close to what a Bitcoin actually is. So understand like how your um, physical cash works or guarantees. So when you take the physical cash, right, over here, what information does it have on the um, on printed on this note. It just mentions the currency amount 2000 and some features to ensure it's real or fake, like this photo and all these things. So it has all these features on the currency notes. 5319. Inda 5319. So it has all these features on the currency note, as well as that's it, right? And also importantly, it has this line over here, if you notice, guaranteed by central government, and it has the sign of the RBI governor. So these are the two most important things to notice, right? So what this mentions is it's just a piece of paper, finally, whatever physical cash you have in your hand. But when you are using that currency note, what makes it a currency note? What makes that just a piece of paper a valid 2000 rupees currency note? Is this signed by the RBI governor guaranteeing that this is contains 2000 rupees value, right? So you have a fiscal cash and it's signed by the RBI governor, and who acts on behalf of the central government, guaranteeing that this is indeed a 2000 rupees note. And this fiscal cash, whoever has that physical cash in their hand, has in their possession, say in their purse or wallet, they are the owner of that physical cash. Now let's try to replicate what a digital cash alternative should be, right? So let's take a digital cash. Let's try to design digital cash from the scratch, and let's see what problems we will uh, face when we try to get a digital cash. So say assume I have digital cash, and let's say when Akshay wants to pay to Bharat, right? Who first of all just map all these physical cash things, whatever we discussed, to the digital cash, but with the condition that there is no centralized entity over here. So there is no centralized entity. So with this condition, the first question is, first of all, who will guarantee that Akshay really has that much money? Say Akshay wants to pay 10 bitcoins. Who will guarantee that Akshay really has 10 bitcoins? So that's the first question. The second question is, who will
చూసిగా ఓకే చెప్తున్నట్టుగా వాడు పంపివ్వాలి చేసేయండి అంటే కూడా చేయమంటారు అని చూసి చెప్పి
Yeah. So who guarantees that Akshay really has those 10 bitcoins? And the second question that we have to look into is, what in the physical world we had this currency note, in the digital world what will it be? Okay, so um, just look like in this perspective, in the physical world, this 10 this 2000 rupees currency note gets its validity just by the RBI governor's signature, right? In the digital world, without any centralized entity, right, we cannot replicate the same setting where I have a RBI governor and he signs that digital cash, like an ID or something stating that this is 2000 rupees or something like that. That's not possible. So in that case, what is then possible in the digital world is, since it's a decentralized uh, um, environment, you have all the nodes participating in that distributed system or in the decentralized environment. Now all the nodes or majority of the nodes The majority of nodes should guarantee that Akshay has really has the 10 bitcoins. So if majority of the nodes tell that Akshay has those 10 bitcoins, then it means Akshay really has those 10 bitcoins. If majority of the nodes don't tell that, if they tell Akshay doesn't have the 10 bitcoins, it means Akshay doesn't have the 10 bitcoins. So that's how digital cash is guaranteed, or it gets its value in a decentralized entity. Okay, so this concept you should understand. So in a physical cash, you have the RBI governor signature, which guarantees that that person, whoever has that currency note in their purse or wallet, has is able to pay that much amount. He is in possession of that much amount, 2,000 rupees or 500 rupees. In the digital environment, without any centralized entity, who guarantees that that person has these many bitcoins, is majority of the nodes should come to a consensus and tell that that person indeed has these many bitcoins. Only then that holds true. If majority of the nodes, whatever the majority of the nodes mention, right, that holds true. So if majority of the nodes try to um, target you and tell that you have zero bitcoins, then it means you have zero bitcoins. If they tell you have 100 bitcoins, it means you have 100 bitcoins. So that's just the hard fact that we have to live with in a decentralized entity. So that's why in Bitcoin we have this rule that 50% of the 51% of the nodes or that hashing power should be honest. So then only these decentralized entities will work out well. Okay, so this is how a digital cash value is guaranteed in a centralized entity. But we didn't look at what the Bitcoin actually represents. Like over here, this currency note in a physical setting, it represents this piece of paper with the sign and everything. Um, Now, Bitcoin, it will represent something like this in the digital world. Assume you have like a message. Uh,
One doubt here. How do
yeah.
these nodes know that, matlab they are able to guarantee, on what basis are they able to guarantee?
On
That
what
is, that
basis?
is, that is a doubt. I mean, how do they know that the balance with Akshay is 10? On how are they verifying that?
Yeah. Okay. Okay. I'll get to it. Okay. Yeah. Um, Saurabh, you have raised your hand. Saurabh. Okay. So let me just continue. So, what is Bitcoin actually in the digital world? So let's look at that. So assume that you have like just a message chit or something in the digital world. Like you just have say like a message containing the terms like Akshay is the payer, right? Akshay, let me just be like that. Just think it like this: payer is Akshay, payee is Bharat. Assume Akshay previously has 10 bitcoins. Just assume. Okay. And the amount transferred is 10 bitcoins. Okay, so this just a message, and this will be the transaction message. So this is what a transaction will look like in a high level overview on Bitcoin. Okay, let's just assume this is how the transaction will look like. Now, this transaction, this transaction, Bharat will propagate to all the nodes, and this will be added in the block. Okay, and assume this transaction is valid, and when we tell valid, what all needs to be checked is whether Akshay has indeed 10 bitcoins. We'll get to that point. Okay, how it checks, and Akshay has not used his 10 bitcoins previously. There's no double spending. Okay, so what I mean by double spending is in your physical cash, when you have the currency note in your hand, is it possible to double spend that currency note? It's not possible, because when you have the currency note, when you are spending it, you physically hand over that note to the person opposite to you, right, the shopkeeper. So that note is now in physical possession of that shopkeeper, and it's not in your physical possession. So even if you want to double spend that physical cash, you won't be able to, because you are not in possession of that currency note. But in a digital setting, right, that's not possible. Okay, so in a digital setting, that double spending is possible, because you can just do like control copy and control paste, and just copy that message again and send, um, try just duplicating the messages and sending. So in digital world, double spending is sort of very cheap to do, and this should be negated in the Bitcoin world. So how does Bitcoin actually deal with this? We'll look at now. So assume this, how your transaction will look like. It just contains the payer, payee details, and the amount that has to be sent, and this is added in the blockchain. Now, what will Bharat do is, say Bharat now wants to send some transaction, some bitcoins to Chandra. So, for example, Bharat, this is transaction 1, and say this is transaction 2. So now payer is Bharat, the payee is Chandra, and the amount, let's say, let's just assume it's the same, let's assume it's like 5 bitcoins. Okay, now let's say we have another transaction, transaction 3. Here payer is, we have payee and then the amount. Let's say it is the same 5 bitcoins, but here payer is Chandra, and then the payee is say some name starting with B. B. Okay, so let's assume this your these are your 3 transactions. Okay, now what will now what happens is, assume this transaction is submitted on the blockchain already. So this is blockchain approved. Okay, now what happens is, when Bharat wants to pay to Chandra 5 bitcoins, what's the proof that he has these 5 bitcoins? Right? The proof is he was part of a transaction previously. Right? This is your proof. He is part of a transaction previously where he got the 10 bitcoins from Akshay, and he is spending from those 10 bitcoins and giving Chandra those 5 bitcoins. So this transaction 2 will have like a pointer to transaction 1 as a proof for Bharat is in possession of 10 bitcoins, or he has sufficient funds to to carry out this transaction 2 and pay 5 bitcoins to Chandra. Okay, now once Chandra gets those 5 bitcoins, if he wants to send the same 5 bitcoins to Dheeraj, right, what's the proof that Chandra is in possession of those 5 bitcoins? The proof is Chandra as a payer was involved in a previous transaction as a payee, where the amount he received was 5 bitcoins. Okay, so now if you see how these 3 transactions are linked, it will be sort of linked in the backward way. So transaction 2 will have a pointer pointing into transaction 1. transaction 3 will be pointing to transaction 2. And your Bitcoin basically is just a series of transactions. That's it. So there is no notion of one Bitcoin is having a specific ID, something like a serial number node. So if you look at this currency note, you will see the serial number node in the corner, right? It's not like that. Current Bitcoin will have a serial number node attached to every one Bitcoin like that. It's not like that. Basically, what a Bitcoin is that it's just a series of transactions. Okay. uh, how it works is when Akshay wants to send to Bharat, he'll just send a message, just like your assume like the entire you have like a WhatsApp interface or something like that. So assume that Akshay and Bharat together, they'll just send out a message stating that Akshay is sending Bharat 10 bitcoins, and this transaction should be added to the blockchain. Assume it's added. Now, if Bharat wants to send 5 bitcoins, he should show the proof that he is in possession of those 5 bitcoins. But from where will he show the proof? He should show that he was a payee in a previous transaction, which is on the blockchain. If that is present, if that proof is able to show, proof as in if he is able to point to that specific transaction, then and since it's added to the blockchain, the previous transaction one, then it means that all the nodes in the blockchain accept that transaction one has occurred, and Akshay has sent 10 bitcoins to Bharat. So transaction one, since it's the blockchain, all the nodes have accepted that Bharat has now 10 bitcoins. Okay. Now using that as a proof, Bharat can send out a new transaction 2 where he pays to Chandra 5 bitcoins. So this should be propagated to the blockchain. And once this is accepted to the blockchain, right? Chandra can send out a new transaction where he states that he want to send Dheeraj 5 bitcoins. Okay, and so everything is just like how you so the world we are living in, right? It's you have all these questions in Bitcoin, like who generates money and who guarantees this money and all these things. Try asking that same questions to your physical cash. What is the guarantee that that physical currency note today you are able to buy all these like for 2000 rupees, if you are able to buy some set of goods, the next day you are not able to buy that same set of goods at that same price, right? You have like inflation and all these things, right? So who sets the prices, how is it determined, and all these things, right? So in the same way all these questions can be asked in the Bitcoin world also. Okay, so that's why they treat Bitcoin as a digital equivalent of the physical cash, and whatever is applicable to your physical cash is applicable to Bitcoin also, right? And finally, if you look at a 2000 rupees note, if you just try to have an analogy with whatever I explained in this Bitcoin, as in a series of transactions. Say if I'm having a 2000 rupee note, the proof that I'm having that 2000 rupee value is I'm having that note in my hand. But from where I got that note, what's the proof is because I have it in my hand physically. It's present. The currency note is present physically, and I was part of a transaction before where my employer had paid me my salary, which consisted of multiple 2000 rupees notes. Out of that, I take one 2000 rupee note and give it to the shopkeeper. Now that note has changed possession physically, it's now in the shopkeeper's hand, and is part of a transaction. So if I just elaborate it over here, right? Your 2000 rupee note was first in Akshay's hand, and he gives it to Bharat. So this is transaction one basically, right? And we don't sort of maintain any information of who gave it to Bharat. So this is sort of private, right? If unless Bharat tells like this 2000 rupee note came from Akshay, the person who Bharat is sending to, say Chandra, is sending to Chandra like 1000 rupees, he need not mention to Chandra that from who he got the 2000 rupees, right? So that is privacy actually. And to Chandra, he can send it to Dheeraj, the same 1000 rupees, right? So this is transaction 1, 2 and 3. So the same thing happens in the Bitcoin, but instead of sending a physical note, you should send just a message stating that you have 10 Bitcoins and I'm paying him 5 Bitcoins, just like that. It need not be like 10 different unique entities or 10 different IDs that need to be sent. It's just a message stating like amount equal to 10 Bitcoins. How in your bank account and everything, you just have like a message stating that you have 1 lakh money or something like that, right? So in the same way, you just have to specify the amount that you want to send, and all the nodes together will accept whether you have that amount or will reject that transaction. That's it. Okay. Now, in this model of Bitcoin, whatever we discussed, right? The way double spending is prevented is you cannot say, for example, if Chandra is in transaction 3, say if Chandra wants to pay some other person, Balu, the same like 5 Bitcoins, he can refer to, so the rule in Bitcoin is, let me just go down. So the rule in Bitcoin is every transaction can be used only once, can be spent only once. Okay, so if I have this transaction 1 which tells Akshay to Bharat and the value is 2000, what did I say, 10 Bitcoins, right? 10 Bitcoins. And transaction 2 is Bharat to Akshay, sorry, Bharat to Chandra, which is 5 Bitcoins, and you have Chandra to Dheeraj, which is again 5 Bitcoins, right? And I mentioned that each of them, the payer should confirm or should show proof that they were part of a previous transaction as a payee. So Bharat will show a proof that he was payee in transaction 1, and Chandra will show proof that he was a payee in transaction 2 in order to send money to Dheeraj. Now, let's say that Chandra is an attacker and he wants to double spend. So let's say Chandra is trying to send Balu 5 Bitcoins. Okay. Now you can just try to say, you can just link, you can tell like, okay, I have these 5 Bitcoins, I am sending it to Balu, and assume that all these transactions are accepted on the blockchain. They are all accepted on the blockchain. Okay. Now what happens is when Chandra wants to spend his 5 Bitcoins to Balu, he has to prove that he was a payee in a previous transaction. He received money in a previous transaction, and that's the source of the money he wants to send to Balu. That he has to prove. Chandra has to prove. Now, what's the proof? He should point to that transaction specifically. Now, he was part of just transaction 2, and if he points to that transaction 2, that will result in an that will make this transaction 4 invalid. Why? Because this transaction 2 can only be spent only once. By the word spent only once, as in it can just be used once. So in transaction 3 already Chandra has used this transaction. He has used his transaction 2 to send money to Dheeraj, telling that this is the proof for my 5 Bitcoins. Now he cannot show that same transaction as a proof in another transaction to send money to Balu. So every transaction can only be spent once, as in it can be shown as a proof to spend money only once. Once it is used, right, you cannot um, reuse the transaction and spend money again. So this is how double spending is prohibited or prevented in blockchain. Sorry, in Bitcoin.
So this linkage is not clear. I mean, how are we linking? That is what the question is in this case. I mean, you're saying Bharat in transaction 2 is getting linked to Bharat in transaction 1.
Right.
In blockchain, how are we doing this basically?
Okay. So um, let's say you have all these data right over here. Okay. What usually happens is you will hash all this data and you get something called as the transaction ID. And Bharat will basically specify what previous transaction ID he was part as a payee to show as proof that he is in possession of 10 bitcoins. Similarly, every transaction will have a transaction ID, and those transaction IDs will be used in the next transaction to point to those. Like the transaction ID acts like a pointer, and basically along with actually all this information, the payer, payee, and the amount, you should have a previous transaction ID. Okay, so do you get this concept?
And this is part of which script in that case? So when I'm in transaction 2,
I've not gone into the script explanation still.
okay,
So this concept, if you understand, it will become easy to understand the script.
okay.
So you should have a question, right? Uh, Automatically. How is it possible that Bharat can say transaction 2 when Bharat is creating to send money to Chandra? How do we ensure that only Bharat can point to transaction 1's transaction ID and say like Chandra doesn't point to this transaction? How is this prevented in Bitcoin? So in your physical cash, if all this is prevented because you have that physical note in your hands, which easily proves your ownership. But in a digital setting, how can Chandra or Bharat prove ownership? So here, the proof what I showed now, as in that previous transaction, it's proof that he was part of the payee. But how can we go a step further and add a condition that it is only Bharat who can spend transaction 1 or
Then it's
can use
prob
transaction 1?
it's probably Bharat's public key which is hashed in the transaction ID above in transaction
Exactly.
1.
So that's where the concept of public and private key comes into picture. So the hash of so the public key of Bharat would be mentioned in this transaction, the pub key of Bharat. And when Bharat wants to use this transaction 1 in which he was a payee, he will specify his, he will sign using his private key or something so that it matches the public key and he can use the transaction 1. So if Chandra wants to use transaction 1, that won't be possible because the corresponding private key um, only Bharat has in possession and not Chandra. Okay. Murali, I have raised your hand. Do you have any question?
Yeah, actually, the Bitcoin, when the first person starting, what will happen? Suppose I have 1,000 Bitcoin. Can I start 1,000 Bitcoin? Who am I invite to join in my blockchain?
Who
How the
will?
people will join in my blockchain?
Okay. Okay. I get your doubt. Okay. I'll answer it. So Varun, Sriman and asked, Akshay is sending to Bharat. Bharat. Okay. Okay. I get your doubt. So let's assume, so it's not the case that all the money I get is just from a single person, right? I can have like multiple sources of my income. Say my parents can give me some money, my employers can give me some money, right? So there will be multiple sources of income. So in Bitcoin, basically, as I mentioned, it's just a list of transactions. So whenever you want to send some money to another person, you should prove that you are part of the transaction in a previous transaction where you are the payee and the amount that you have is sufficient to send money to that person, whoever you are sending to. So for example, um, say you have transaction 1, you have transaction 2, and say transaction 3. Okay, and assume that in all these transactions Akshay had received, so it can be any person, okay, sending it to Akshay. So it can be any person sending it to Akshay, and in all these transactions, assume all these are accepted in the blockchain. Okay, and let's give the amount 5 Bitcoin, 10 Bitcoins, and then 5 Bitcoins. So this is the amount, and Akshay is the payee in all these transactions. Now let's say Akshay wants to submit a new transaction where it's transaction 4. Akshay wants to send it to Chandra. Akshay wants to send it to Bharat, 10 Bitcoins. Okay. Now, what Akshay can do is, he can either specify the transaction ID. He can specify it as proof that he was a payee in transaction 2. Okay, and the ownership is of course proved using your public and private key. Okay, so he can specify he was the payee in transaction 2 and he has these 10 Bitcoins, and he can send these 10 Bitcoins to Bharat. That is one. Or instead what he can do is, he can create another transaction, okay, where he sends the same amount to Bharat, but instead of pointing to the transaction 2, instead what he can do is, he can specify multiple transactions, as in transaction 1 and transaction 3. So he can specify that he was a PE in all these transactions, right? And the amount put together in all these transactions is sufficient for him to send 10 Bitcoins to Bharat. Okay, so do you get the logic? So it's not like only one transaction should be pointed to in this. You should just be part of. Say, if I want to spend 10 Bitcoin, say like this transaction wasn't there, means it's not the case that Akshay cannot send Bharat 10 Bitcoins in a single transaction. He can um, collate all these multiple transactions that he was part of and spend those transactions in a single go and send it to Bharat. Okay, so whether he wants to use transaction 2 or whether he wants to use transaction 1 and 3 depends on Akshay's choice if he wants to send it to Bharat. So it's just view it in the physical cash analogy, right? You are being asked, you have to pay the shopkeeper 100 rupees. Now you have like 5 20 rupee notes, or you have a single 100 rupee note. You have a 20 rupee note, you got it from your parent, and the single 100 rupee note, you got it from your friend. So it's up to you whether you want to use the 5 20 rupee notes or just a single 100 rupee note. So it's just that analogy, that's it. He should just prove he was a pay in 1 or 2 transactions, so that in order to show that he has sufficient balance. So another key term in this uh, the key analogy in this Bitcoin is, there is no notion of an account in Bitcoin. So when I tell like Akshay should prove that he has sufficient balance of 10 Bitcoins, the the proof is he should not show like in your real world how you have like a passbook and a bank, and when you want to do some bank transaction, you have to show your bank balance has this much amount, right? It's not like that in Bitcoins. Think in your physical world setting, where if I want to assume like you don't have a bank account, so what will happen? um, at your home you might have like lots of cash, but when you come out you will just have 2000 rupees note, right? So whatever you have in your hand, that only you can spend it. Okay, so similarly whatever transactions you are part of pay, you are a payee in all the previous transactions, those you can link to and spend that amount. And and all these will basically be encrypted using your public key, so that only you can spend those, you can point to those transactions to spend those amounts using your private key. No one else can spend the amount because they don't have your private key, which is private to you alone. It's a secret. And yeah, that's it. So there is no sort of like an account where like an account model, like say Akshay is given a unique ID where um, if this ID is there, it's Akshay, name is Akshay, and just a balance or something. So that's not there in Bitcoin. There is something called as wallet software. We'll discuss the concept of wallet software later, probably next week. But just keep in mind that there is no account or something where you have a name associated with an account ID or something like that. Notion, it's not there. Okay. So Shriman has asked a question. Let me change the example. Transaction 3, Bharat sends to Chandra 7 Bitcoin. Bharat sends to Krishna 2 Bitcoin. Okay. So Shriman, that's a good example, right? What you have asked. So if I get your question properly, so say what you are saying is Akshay is sending to Bharat 10 Bitcoins. That is transaction 1. Now transaction 2, Bharat is sending to Chandra 5 Bitcoins. Okay, and now, so all these two are accepted, these two on the blockchain. Now you might ask a question. So that's what Shriman has asked, like an intuitive question. Bharat has included the transaction ID of transaction 1, so that he shows proof that he has 10 Bitcoins, and out of it he's spending 5 Bitcoins. But remaining 5 Bitcoins still Bharat is in possession of, and he can sort of write a new transaction stating that Bharat wants to send it to Dheeraj 5 Bitcoins, and the proof is part of this transaction 1. But I had mentioned previously that every transaction can be spent only once. That is, it can be just referred only once. So if transaction 2 has referred already, this referring of transaction 3 to transaction 1 is invalid. Then you might ask what happens to the remaining 5 Bitcoins of Bharat. So what happens is, as part of this transaction 2, there is another transaction which is submitted automatically to the Bitcoin, right? When Bharat submits this transaction 2, he submits another transaction, say 2B, where it just mentions Bharat is sending to Bharat himself 5 Bitcoins. Okay, so transaction 2B will actually won't be like a separate transaction. This will be sort of part of the same transaction 2. So now let me just rewrite this, right? So Bharat to Chandra 5 Bitcoin, and Bharat to Bharat 5 Bitcoin. So this two of these things put together will be in transaction 2. Okay, and what happens is Bharat, if he wants to send it to Dheeraj, he can refer to this transaction 2 instead of referring to transaction 1. So it's just viewed in the physical cash analogy. If you have a 100 rupee note and say Bharat has this 10 Bitcoins, right? He got it from Akshay. Now in the physical notation, in the physical cash world, Bharat will have 2000 rupee note, and he wants to give Chandra just 1000 rupees. So what he will do, he will give Chandra the 2000 rupees, right? And he will get change as 1000 rupee, and that will be like sort of a new currency note basically in Bharat's possession. Okay, so the original whatever he got from Akshay, the 2000 rupee note, he has handed it over to Chandra. So that possession he has lost, but in return he will get a change. So that change he can use it in the next transaction. So this basically this Bharat to Bharat, right? This basically is known as your change, the change transaction. So Bharat can, if he wants to send Dheeraj the remaining 5 bitcoins, he can refer to transaction 2, stating that he has proof that he has 5 bitcoins. Now instead of referring to transaction 1, because transaction 1 is already spent in transaction 2 and he cannot refer to it again. Okay. Now there is you might ask a question, right? The next follow-up question would be, if Bharat is, let me just clean this up. Let me just redraw this. Okay. So Bharat to Chandra and then Bharat to Bharat, 5 bitcoins, and then you have transaction 3, and then you have transaction 4. So assume all these 3 are accepted on the blockchain, and then you have transaction 4, which is a new one, it's set to be accepted, and let's say Bharat sends it to Dheeraj, 5 bitcoins. Okay, now let's say Chandra wants to send to Balu 5 bitcoins, right? So Bharat, in order for this transaction, this will be pointing to transaction 1, this will be pointing to transaction 2. Okay, so this is where he got the change and it will be pointing. Now, so basically, now if Chandra wants to send Balu 5 bitcoins, where is the transaction proof that he has those 5 bitcoins, he received 5 bitcoins as a payee? It's basically transaction 2 over here. But I mentioned that the transaction 2 is already, any transaction should be spent only once, so it can be referred only once. Then how can, so if transaction 2 is already spent as in linked in transaction 3, how can Chandra in a new transaction 4 specify transaction 2? Right, you might have that question. So when we mean a transaction should be spent only once, it's not just the entire transaction, it's like a output of the transaction. So that's where we get to know, we get the term UTXO, which is unspent transaction output. So similar to how we saw in this example, right? Which example? Yeah, so in this example, we mentioned that Akshay can have multiple, he can point to multiple transactions, stating that all these transactions amount put together, he has these many bitcoins. So basically, he's having like multiple inputs as proof to show that he has 10 bitcoins. Similarly, in a transaction, you can have multiple outputs. Okay, every output in a transaction should be spent only once. So in the previous explanation, I mentioned a transaction can be spent only once, but that's a small error in that statement. It should be fine-tuned to state that every output in a transaction should be spent only once. So when Bharat needs to spend the 5 bitcoins to Dheeraj, he will specify output 2 belonging to transaction 2. When Chandra wants to spend Balu 5 bitcoins, he will refer to output 1 belonging to transaction 2. Okay, so do you get the point I'm trying to put forth? Right. So from this is where we get the term unspent transaction outputs. So every transaction can have multiple outputs, and every output in a transaction should be unspent if it needs to be used as an input. Okay, and this is basically the Bitcoin model. So Bitcoin basically, when you mention how does what does Bitcoin actually uh, uh, you might ask a question like Akshay's account is not. I mentioned that Akshay, they it don't have like so say in your bank, right? When you want to check your balance, what you do, you just key in your ID and your account number, and it shows bank balance is 1 lakh or something. In Bitcoin, there is nothing like a Bitcoin balance or something. What happens is Bitcoin just maintains what is called as a UTXO set. It's just a database. And in the database, what it will contain is, okay, all the unspent transaction outputs, it will just contain. So it will contain, okay, transaction 1, output 1 is unspent, transaction 2, output 1, and then output 2 is unspent, like that. Now what happens is when a new block is added to the blockchain, say say all these transactions are added in a block, and that block is added to the blockchain, this UTXO set will be updated. So for example, over here, what will happen is, say when transaction 1, 2, 3 and 4 are added, right? What will happen is it will see that transaction, it should first, how will it verify a transaction? So it will see whether this transaction 1 is pointing to a previous transaction output and Akshay really is the owner, okay, and that should be present in the UTXO set. So assume that transaction 1 output alone is present for now in my UTXO set. So we'll go step by step, right? So assume that transaction 1 output 1 is alone present, and if I submit transaction 2, it will point to transaction 1 output 1. So what it will do is it will check whether transaction 1 output 1 is there, that is check 1. Okay, whether transaction is present in the UTXO. If that check is present, it will now see whether this public and private key and all these things matches. And once these two conditions pass, what it will do is it will remove this transaction 1 from the UTXO set, that specific output, and it will create a new output called as transaction 2 output 1. Now when Bharat has to transaction 2 two outputs, right? So it will create two outputs, output 1 and output 2. And now when Bharat needs to spend transaction 3, he will make use of this unspent transaction. So what happens when transaction 3 is submitted is, this will get removed from the UTXO set. This will get removed and a new transaction output will be created, transaction 3 output 1. And when transaction 4 is admitted to the blockchain, uh, it's referring to transaction 2's output 1, right? So that will be spent, that will be deleted from the UTXO set, and in its place transaction 4 output 1 will be created. So basically your Bitcoin will just maintain a UTXO set, and in this UTXO set it maintains all the unspent transaction outputs, the transaction ID and the output number, what are all is unspent. And you should make sure that when you submit a transaction, you should ensure that you are a payee in the previous transaction, and only then it will refer to a unspent transaction output and you can spend that amount. And after every transaction, since we have this notion that the transaction output is just to be spent once, right? So you might ask a question, why should I delete this transaction output 1? That's because I should not do double spending. So it should only be spendable once, right? This transaction output 1. If I don't delete this output 1 when I submit transaction 2, And what happens is this transaction once output 1 of 10 bitcoins, I can use it in another transaction as a proof stating that I have 10 bitcoins. Okay. So this is the concept of Bitcoin and how it uh, how this term called UTXO set. Now you might have a question like then what did we know? What did we study about script sig and script public and all those things? So we have like 10 more minutes left actually. So giving
One
a
small doubt on this. A UTXO is a auto-generated script because the pair will not put this. Is it generated by the network itself?
Yeah, so whenever you mention it's auto generated by the network, right? It's not something, it's like, it's like every node in the network should maintain this set, every honest node. So every node, what it will do is when it receives a block, okay, so whether it mines the block, whether it solves the puzzle or not, irrespective of that, every node in the blockchain should, if it's a honest node, if they really want the blockchain to be trusted, from where does the trust come from? The trust is majority of the nodes are honest, right? So in that case, most of the nodes should maintain this UTXO set. And what they should do is they should look at the blocks that are getting propagated across the network. If they find out, say, the blockchain is updated with a block is added to the blockchain, they should read all the transactions in that block, strike off all the spent transaction outputs, and add new transaction outputs, the unspent ones. So they should ensure that the UTXO set is up to date in their local copy. Yes, so Shriman has asked a question, is it the responsibility of the sender to remember the transaction ID of the previous transaction? Exactly, yes. The sender has to remember the previous transaction ID. So remember it as a same physical cash analogy, right? I have three 2000 rupee notes I got from my parent, from my employer, and from my friend. I got it at different places. So I could have kept it at all the three in my same wallet, or like different sections of the wallet. So I should remember where I had kept that physical currency note. If I forget where I kept it, say I could have kept it in a book, or I could have kept it in my pouch, or I could have just kept it on my table, right? So if I forget where I kept it, the 2000 rupees is lost forever. So they should remember the previous transaction in which they were part of. If they forget that transaction ID, if they are not able to find it, then that amount, whatever they received, is lost forever. So that's the thing with Bitcoin, and specifically for that. So assume in your physical cash, right? If you don't have a purse, how will you carry all that physical notes? You should carry it in your hand, and it might be the case that you can lose some of the currency notes, right? So that's why you have a wallet in your pant where you place that wallet, you collect all the currency notes, keep it in that same wallet throughout the day, and you spend it from there. So similarly, in Bitcoin, there is wallet software where you have to mention where it sort of helps the user in finding all these previous transaction IDs and getting it together, so that say like you have like a nice graphical interface where you can just specify how much bitcoins I need to send, and to whom should I send. Now it's just the wallet to decide which previous transactions it should use or not. So all this bookkeeping of all the previous transactions is done by a separate software called as the wallet software. It can also be found by searching the blockchain. That's exactly what your wallet software will do. So does that answer your question, Shriman? Okay. So when yeah. So Mahendra, you had a doubt or something where you asking?
it was related to that UTXO. So how is it getting generated? That's what I was saying. What will trigger this UTXO basically?
How is it getting generated as in?
So when I make a transaction, I send say some bitcoins to say a payee.
Okay,
Then the UTXO has to get updated, right? With this transaction, it should check and then it should remove the previous one.
right,
So
right.
how is the script getting run? How is it running the script to do these kind of transactions on the UTXO?
No, so basically in your block you will have all these transactions put together, okay, and this block will be sent out to all the nodes, okay, and what happens is all the nodes will independently look at every transaction in the block and update the UTXO set.
Yeah,
So
that's what I'm trying to understand. When we say all the nodes look into this, what is that actually? Is that some code written somewhere, or what is
okay,
happening?
so you are asking like as in how do you start a node in the first place, right?
I'm saying, how is it validating that this has happened now? The node is validating and then it is updating the UTXO. So that code is written somewhere
Yeah.
in the node,
Okay,
or
so if you go to like Bitcoin website or something, there'll be like a source code. You should basically download that source code and start executing. That's it. So that code will basically have these rules within it.
okay, okay,
So it's finally it's just a program. So the program will have it will have like a network component where it gets a block, right? It will receive a block over the network, and it will look at all the transactions in that block, and it will update the UTXO set. And this UTXO set is just like a local, say, a database or an array or something that you maintain locally in a file. And every node will maintain locally a file. And what Bitcoin achieves is after, say, 20 blocks are added in the blockchain, since majority of the nodes are honest, the guarantee that Bitcoin provides is all these different nodes participating in the Bitcoin will have the same UTXO set if they compare it together. If they compare and see with every other node, right? They will have the same UTXO set, that is the unspent transaction outputs. After these 20 blocks have been added to the blockchain. So that's the guarantee that the Bitcoin provides.
sure. Thank you so much.
Yeah.
Yeah.
So it's a code that executes all these things, but it executes independently in its local system. That's it. It doesn't have like a centralized copy of UTXO set. Everything is just happens independently, and that's the guarantee that Bitcoin provides. So so someone had asked the script SIG and script public key and those things, right? So the details I will go in next week's live session. Like we don't have time to cover that in detail. I have slides actually, but just giving a sneak peek, right? What does script SIG and do? So I mentioned that. The UTXO set will contain the unspent transaction outputs, and when I'm creating a new transaction, it should sort of basically point to this unspent, the previous unspent transaction output, right? So, and that will be deleted, and this new transaction output will be added to the UTXO set. Now, but we didn't discuss how does Akshay, like transaction one is Bharat is the receiver, right? So Bharat is the owner of that transaction one, output one, and it should only be the case that Bharat can be able to use that transaction one's output one, and no one else can use. So if I just maintain just transaction one output one, it can be used by any user, not just Bharat. Anyone can just claim that they were the payee and they can use it. So what is usually present along with this transaction output is it also contains a script. Assume this the script. In other words, it's basically a lock. Okay, a lock containing some instructions. A lock, so lock is basically like a function, okay, function with some code within it. And what happens is, how do we, apart from just say Bharat, apart from just specifying that he was the payee in this transactions output one, he should also provide a parameter to this lock, parameters or inputs to this lock, such that when I execute this function with this inputs, it should return me 1. It should succeed basically. If it returns a 0 or if it fails, then it means Bharat is not the owner of this transaction output. So if I just erase this, so it's not just your transaction output 1, along with it there will be a lock script. And a lock script is basically just a function which some code within it with some instructions. But in anyone, in order to use this transaction output, should have um, the condition to use this transaction output is present in this log script. So this sort of prevents, it sort of guarantees that only the actual payee can use this transaction output one, and no one else can use this transaction output. Okay, and this log script, which we'll be discussing in detail in the next class, will be something to do with your public and private key, such that the function code will contain some instructions based on your public key, and your parameter will basically be related to your private key. So private key will be in the sole possession of that particular person, right? And the public key will be known to everyone. So if someone wants to send money to, say Akshay wants to send to Bharat, they can just like that generate a log script using the public key of Bharat, which is known to everyone. But only Bharat can be able to use that transaction output because he is in possession of that private key. He alone is in possession. So only if he passes it, passes the input, he can make use of that unspent transaction output. So that's what we usually call the script sig and script public key. This log script basically. So it provides the conditions for which this transaction output can be used or not. So does this logic, is this logic clear?
Yes, sir.
Okay. So right. So I guess these are the questions sort of answered. So does anyone else have any other questions? So we'll be going into the details of blockchain into more depth next week. So I didn't want to just like that use all the terms directly in the first go itself. Yeah, Mahindra, I'll have a look at the coefficient question. I'm not sure of the formula, so I should.
Yeah, actually, I have put the formula also, which is given there. So it is given the bits as 4 bytes, and it is saying you take first byte as the index and the rest three as the coefficient.
Okay.
So my question is, if instead of four we have say 8 or 12, then in that case, how many bytes should we take it as index and how many should we take it as coefficient? That is the
No,
confusion.
so it's not like so. Just like you're asking a hypothetical question. So like if it has more than 4 bits.
So you're saying it cannot have more than four?
No, so the thing is, there is a specific format called blockchain, called a block header. So the block, so there's like a formula for how the difficulty, as in you want to solve a puzzle in order to add a block to the blockchain. How difficult that puzzle should be is sort of independently found out by every participating node. Okay, and only if the incoming block satisfies that condition, only then that block will be added to the blockchain. Okay, so say like lower the number, higher the difficulty. Assume that. So 1 is the most difficult and 100 is least difficult. And what happens is all the nodes will be following a set difficulty standard for some period of time, say difficulty 50. Right, difficulty 50 as in it takes those many iterations or that much time to okay, so the ordering should be opposite then. So higher the number, higher the difficulty. Let's keep it like that. So 100 means it's the most difficult, 1 means least difficult. Okay, so 100 difficulty, it will take 100 hours, 50 means it will take 50 hours. So what happens is the blockchain code as it is, every independent node will be executing this Bitcoin code. And what they will do is whenever they receive a new block, they will check whether that block is having block as whether the miner has solved the puzzle. It will check that. The second thing it will check is whether the miner has solved the puzzle with a specified difficulty. Okay, so the difficulty, sorry. So the difficulty is basically like number of time or number of iterations it has to do. So there is like a condition for that. Now that difficulty you cannot be how will it how will the miner node specify to the other blocks that what difficulty it assumed it has used, right? It has solved. So that is basically this target or something. And in that block, there's like a specific format, and it will be using 4 bytes for to mention what difficulty it used. So it won't be more than 4 bytes. That's like a set format mostly.
Actually, in one of the questions, it is given more than four. So that's what the
Is it okay? Then
yeah.
no, it won't be the case. It's more than 4 bytes. I'll have a look at it. So it will be fixed for sure. Whether it's 8 bytes or 4 bytes, I'm not sure. So maybe for simple explanation in the question, in the explanation, they would have mentioned 4 bytes, but it's not that case too. Wait. Uh, Bitcoin difficulty. Yeah, probably you can just post it in the forum. I can look at it and tell.
Sure, sure. No worries. I will do that.
Yeah. Okay. So any other queries you have? So we'll go into the details of blockchain the next week session. It will at least take another 2 classes or something to get into the details of Bitcoin actually, because like they're like new terms related to Bitcoin. I don't want to hurry and just finish off the explanation in just one class in one sitting. So any other queries you have? Okay, so if there are no queries, then we can end this session. Thank you all for attending and making the session interactive. Yeah, see you all in the next session, Saturday, same timing, 6 to 8. Yeah. Thanks, Shriman. Thanks, Mahendra. Thanks, Anbaras. Yeah, thank you. Yeah. Thank you all. See you next week.